experiment of RC circuit. Objectives: to study charging and discharging characteristic of capacitor and to find the time constant of the RC circuit. Apparatus of this experiment: discharge circuit containing several resistors, one Farad capacitor, and battery holders. Voltage current sensor, batteries, connected wires, computer interface, and data studio software. Capacitor is made of dielectric material within two parallel plates. When a battery is connected to capacitor, positive charge collects on one plate and negative charge collects on other plate until potential difference between the two is equal the voltage of battery. The capacitance C is defined as the ratio between Q and V, where Q is the charge needed to produce a given voltage V across the capacitor. Some electrical circuits contain both resistors and capacitors. These are called RC circuits. If the initial voltage applied to an RC circuit is V0, the capacitance of the capacitor is C, and the resistance of the resistors is R. Then the amount of time T it takes for the capacitor to reach the charge U is given by. If both sides of equation A2 are divided by C, the following equation results, where V is the voltage of capacitors at time T, the voltage of across the resistors at time is given by. If both sides of equation H4 are divided by R, the following equation results, where I is the current of capacitors at time T. Similarly, the discharging of capacitor is given by the equations, where V0 is the voltage across the capacitors at time T equal 0. Time constant. The term RC in the exponent is referred as the time constant. The time constant is the amount of time it takes for the charge of the capacitor to equal 63.2% of its final value when charging, or 36.8% of its initial value when discharging. Similarly, the time constant applies for both the voltage and the current in the capacitors of an RC circuit. A general rule of thumb: the time necessary for the capacitor of an RC circuit to nearly completely charge to V0 or discharge to 0 is 4 RC. A graph voltage varies time for charging and discharging a capacitor. As charging progresses, current decreases and charge increases.
In this experiment, we will use this circuit, which in fact consists of the capacitor. This is the capacitor, this one, and this is a capacitor of value 1 farad. Its capacitance is 1 farad, and we use resistance. In fact, in this circuit there are 3 options. We can use 10 ohms or 33 ohms or 100 ohms, but I will do this experiment using the 10 ohms because this will make the charging process and the discharging process faster. But we may switch to this one. We will charge and discharge the capacitor and see the value of the voltage, how it changes with time, and the value of the current, how it changes with time. In this circuit we use 2 batteries. Each battery is 1.5 volts, so this represents a voltage of 3 volts. Now I need at the beginning just to show you, I will switch to this lamp I will switch this to this lamp and make a discharge to show you how the current starts strong, then it becomes smaller and smaller. You see the light, then it fades gradually because the current becomes smaller and smaller and smaller and smaller. Now in this circuit, since the capacitor is 1 farad and the resistance is 10 ohms, this means the time constant for this circuit RC is 10 times 1, which is 10 seconds. So we expect the capacitor to become fully charged in 40 seconds, and when we discharge the capacitor it becomes empty also after 40 seconds. Now this circuit is connected with this instrument. This is a current detector and the voltage detector. This is the current detector and this is the voltage detector. Both are connected to this spark module, which is connected to the computer through this wire, a USB connection here, and the computer will show us the data. Now this is a switch. In this switch we can go to the charge or discharge. So this is the discharge side. So I am now discharging, and this is the charge side. So I can go like this. When I close this switch now here, it will start charging. Before I start charging, I will start recording the data here. I will press record and we will see the curve on the screen. Okay, I will start recording. Okay, here you can see this is the curve for voltage with time, and we can see the voltage is increasing now, increasing and increasing and increasing, and I expect the voltage after 40 seconds, which is the full time, to become 3 volts, which is the maximum voltage. So I will wait for 40 seconds here, the counter, the time, then I will stop after 40 seconds. Okay, I will give 5 more seconds. Okay, I stop recording. This is the curve, this is the increasing voltage, and you can see that the maximum here, the maximum is exactly at 3 volts. Here. 3 volts, which is the voltage of the battery. This is the maximum voltage of the capacitor after 40 seconds. Now we need to record this data from this table. This table shows us the value of the voltage at any moment. So in our lab report, we need to record, in fact, these values. We need to write down what is the value of the voltage, what is the time at voltage 0, what was the time when the voltage is 0.5, what is the time when the voltage is 1 volt, 1.5, 2, 2.5, and the 3, and so on. So I used the data in the table and recorded the required values in the table number 1 of this experiment. This is the table with the data inside. Here at the top are the voltage of the battery, 3 volts, the resistance 10 ohms, the capacitance of the capacitor is 1 farad, and these are the values V with T. And in this experiment you need to make a graph with V as function of T, which is supposed to look like exactly like this one. This how should your graph look like. Now I will switch to the discharging experiment. Okay, now in the discharging part I will move this switch to the discharging side here, and at the same moment I will start recording the data on the screen. I will show you. So I will press record, and at the same moment I will start discharging the capacitor. Here you can see the voltage now starts from 3 here at this point, and it decreases, and I expect the voltage to become 0 after 40 seconds, approximately 40 seconds. So we are waiting. The time is still now 21 seconds, 22 seconds, 23. Now it's 40 seconds, 42, 43, 44, 45, stop. So this is the decreasing voltage, and you can see it's approximately 0 after 40 seconds. It's not exactly 0 because this is an asymptote. This is an exponential function. So I will do the same as I did in the charging part. I will record the data in the table and show you the data in the table. Okay, now I have collected the data from this table, and this was the result in the table number 2. Here you can see the voltage 3 volts, the resistance 10, the capacitors 1, and these are the values of the voltage and the corresponding values of time. This is a column you need to fill yourself by calculating the logarithm of V0 over Vc. This is Vc, and this is V0, which is a fixed value of 3. And I will show you now why do we need to calculate this value, which is the logarithm. Okay, this is the equation for the capacitor voltage. We know from the class, Vc is the maximum voltage, which is the battery voltage denoted by V0 in this experiment. I can divide both sides by V0. It becomes Vc over V0 equals E negative t over tau. Now if I calculate the natural logarithm for both sides, it becomes ln Vc over V0 equals negative t over tau. To get rid of the negative sign, I can flip the logarithm. Instead of Vc over V0, it becomes V0 over Vc. This is one of the properties of the natural logarithm, and the right hand side is t over 1 over tau, which can be written as ln V0 over C is 1 over tau t. Now this is similar to a linear equation y equal mx. If I use the logarithm of V0 over Vc as the y-axis and t as the x-axis, I will get a straight line with a slope 1 over tau like this. So in this report you will make a graph on which you will put logarithm V0 over Vc on the y-axis, t on the x-axis. You will get a straight line. The slope of this straight line represents the reciprocal of the time constant of this circuit. This is why we need to calculate this value in the table. There's a certain special column for this value. Okay, that's it for this experiment.